In physics, power is basically how quickly work is done or energy is transferred. The formula you see here shows that power, represented by P, is equal to the work done, W, divided by the time, T, it takes to do that work. So power tells us how fast energy is being used, which helps us measure the rate of energy transfer in different processes. Now let's focus on the unit used to measure power, which is called the watt. Since energy and work are measured in joules, power is measured in joules per second. To make it easier, this rate has its own name. 1 watt equals 1 joule per second. So whenever you hear about watts, just remember it's equivalent to a joule per second. Imagine one paintball representing 1 joule of energy. The paintball itself stands for the amount of energy you have. We'll build on this analogy to explore how energy relates to power. Imagination. A paintball gun that shoots 1 paintball every second. That would be 1 joule per second. This steady, slow, and consistent firing rate shows how a 1-watt device delivers energy. It's not about how accurate each shot is, but how regularly those shots come over time. So, power is really the pace at which energy is delivered, with 1 paintball per second being a simple way to picture 1 watt. A small digital clock uses about 3 watts of power. To give you a better sense of what that means, imagine it as firing 3 paintballs every second. This is a simple way to visualize the low energy consumption. It's like a steady, gentle drip rather than a sudden burst of power. This helps frame how little energy such a device actually uses in everyday terms. An old-fashioned filament light bulb uses 60 watts of power, which means it's putting out a steady amount of energy. To help visualize this, think of it as firing 60 paintballs every second at a canvas. This means the canvas is getting hit more frequently and with more force, similar to how the light bulb consumes more energy to produce its brightness. This analogy helps us understand how conventional bulbs work in terms of power usage and impact. A microwave oven uses about 1,000 watts of power, which is the same as 1 kilowatt. To help visualize this, imagine a machine gun firing 1,000 paintballs every single second. That kind of energy delivery is huge and can cause a lot of damage to any surface it hits. This analogy helps us understand just how powerful a microwave oven is in terms of the energy it releases. If you found this presentation helpful, I encourage you to visit physicsib.com. It offers a structured and interactive course designed to guide you through the key concepts step by step, helping to deepen your understanding and practice in a clear, organized way. This resource can be a great next step to build on what we've covered so far. To make further progress, consider subscribing for more content like this. Also, feel free to visit physicsib.com, where you'll find a structured and interactive course designed to support your learning. Thank you for watching.